This is 40 Days of Chemistry, Part 8, and this time we're going to be looking at acid rain, the big questions about acid rain. So it's 9.3.2, and this is Part A. And for acid rain, there's a general sequence of things you've got to talk about. First of all is the origins of nitrogen oxides and sulfur dioxide. You need to know that nitrogen oxides refers to the single oxygen nitrides which actually contribute to acid rain, which is NO and NO2, and there's formulas there in case you're curious. You need to be aware there's natural sources of both these oxides. First of all, sulfur dioxide comes from combustion of sulfur during volcanic eruptions, and also combustion of sulfur-containing plants during bushfires, and there's an equation for the natural production of sulfur dioxide. Nitrogen oxides, they can come from soil bacteria, but also the high temperatures of lightning strikes can cause atmospheric nitrogen oxygen to combine to form both nitrogen dioxide and nitric oxide. Industrial sources. Now there's a whole range of industrial sources, mainly to do with combustion. And the first one, if you've got combustion of sulfur-containing fossil fuels, you're going to get sulfur dioxide, and that equation is exactly the same as that equation up there. The other way we can get sulfur dioxides into the air is something we learned about when we studied AES in lead smelting. And when they smelt lead, they react the lead sulfide with oxygen to produce lead and sulfur dioxide. That contributes a whole lot of sulfur dioxide pollution, but as we know in Port Pirie, that also produces lead pollution. That's an aside for this particular focus area. The next thing is nitrogen oxides. Combustion of nitrogen-containing fossil fuels will cause nitrogen oxides to form, but also the high temperatures of the combustion engines can also cause nitrogen and oxygen to form. So there are natural and industrial sources of both these gases. And what do these gases do? Well, these gases actually react with water in the atmosphere to produce acid rain. It's very important you're aware that that rain is naturally slightly acidic. It's got a pH of about 5 to 6 due to the fact that carbon dioxide dissolves in water to produce carbonic acid. But acid rain by definition has a pH of about less than 5, and that's mainly due to sulfur dioxides and nitrogen oxides. Sulfur dioxide reacts with water to produce sulfurous acid, which is this one here, which then reacts with oxygen to produce sulfuric acid, the one we're more familiar with. Nitric oxide can react with oxygen to produce nitrogen dioxide, and that nitrogen dioxide then reacts with water to produce nitric acid and also nitrous acid, and the nitrous acid then can react with oxygen to produce nitric acid, the one we're aware of. Don't forget as well, if they're talking about problems with these oxides, don't forget that nitrogen oxides have other problems apart from acid rain. Don't forget that nitrogen dioxide in particular is one of the things that causes ground level ozone and smog, so always be aware to mention that if you can. Now acid rain has some pretty big problems on the built environment. First of all, it dissolves the calcium carbonate, which is the main component of marble, cement and concrete, which is a big part of our built environment, and there's an equation you can use there. It also increases the corrosion rates of metals. In our studies of shipwrecks, corrosion and conservation, we know that acidic conditions actually increase the oxidation rates of metals. On the natural environment, acid rain leads to acidification of waterways, particularly lakes, which can lead to death of aquatic plants and animals, which is bad for the ecosystems. It can damage the leaves of trees. It can dissolve their waxy coatings, for example, which leads to death of the trees, and you can see some deforestation happening here and some damage to leaves down here. Acid rain also leaches nutrients from the soil, such as calcium and magnesium, which are needed by plants, and also the acid rain can actually dissolve minerals that would otherwise be insoluble, such as aluminium minerals and also heavy metal minerals, and those ions are toxic and they can pollute the soil and waterways as well. So the evidence is the next thing we need to talk about. Is what is the evidence that we have these gases producing problems? And well, the first thing we say is, what I like to say is, despite the difficulties in obtaining evidence about nitrogen oxides and sulfur dioxides in the atmosphere and determining the exact ratio of natural to anthropogenic contributions, and then I'd say the difficulties being like the fact that they're in low concentration, the fact that they're highly soluble in water so it's hard to measure them, the fact that instrumentation is only around for 50 years so we haven't got a long track record of instrumentation. But despite those difficulties in measuring the contributions of nitrogen oxides and sulfur dioxides, particularly from people, there is growing evidence that acid rain problems are anthropogenic. And the three big ones I'd like you to talk about are, first of all, that ice core samples have shown increased nitrogen oxide concentrations in the atmosphere since the Industrial Revolution, the fact that acid rain damage is localized to regions of high industrial activity. If we skip back to the previous slide, we can see a picture where it shows this map of the world here, and you've got these green regions representing places of high acid rain damage, which are in regions of high industrial activity. And also modern satellite-based systems can monitor sulfur dioxides and nitrogen oxides plumes from industry. And one of the satellites that does this, or one of the instruments that does this, is the OMI, the Ozone Monitoring Instrument, the older version of the Ozone Monitoring Instrument, which is on one of the older satellites are. We know that OMPS is the one they use now on the Suomi MPP satellite, but this OMI can actually measure sulfur dioxides and nitrogen oxides. And here's a couple of maps to show that. First of all, in 2006-2007, it showed the main sources of nitrogen oxides in the atmosphere, and it's clear that these sources are clustered around highly industrial regions. It might be hard to see some of these, but in regions of heavy industry, you do have a lot of nitrogen oxides. They can also measure sulfur oxides or sulfur dioxide. This is a measure of sulfur dioxide over eastern USA in 2005-2007 using that same instrument. And I'll move this down a bit to show you the exact region. It's this region of America here on this map, and you can see it's the big cities where sulfur dioxide is being produced. Hence, the sulfur dioxide problem is obviously anthropogenic. And so the reason we talk about this evidence and difficulties is because most of these questions are discuss or assesses. You've got to talk about points for and against. And the way I'd frame it, despite there are difficulties in measuring these gases and despite the fact it's difficult to prove they're anthropogenic, there is more and more evidence nowadays to suggest that yes, the problems caused by acid rain are anthropogenic. So that's our for and against style thing. Often these questions are evaluate questions too, and evaluate requires a criteria. And the dot point itself says summarise the industrial origins of sulfur dioxide and oxides of nitrogen and evaluate reasons for their concern about the release into the environment. So this is the thing here, the evaluate reasons for concern about their release into the environment. So what are the reasons for concern, or what would be the criteria for having concern about these gases? And the criteria I can think of are, first of all, do these gases actually have a harmful impact on the built or natural environment? And I would probably say that yes, it's pretty clear that they do have a harmful impact on the natural and built environment. Are the problems anthropogenic? Well, the evidence suggests that yes, they're anthropogenic problems. Is that problem likely to increase? Yes, it is, with the increased industrialization of the world. Can anything be done? Yes, there are things that can be done about it. So therefore, based on this criteria, there are 4 reasons why we should be concerned, and we can do something about it. But because we haven't got much space in the HSC exam, we've got to write if we're to write an evaluate, you've got to write introduction, points for and against, a criteria and a judgment. I'd probably try and work my judgment and criteria together. So that's one I've tried to put together to be like a combined judgment and criteria if we were asked to evaluate the concerns or evaluate why we shouldn't release these gases into the atmosphere. If you've got to talk about ways we can stop these gases being released, there's a whole range of reasons. Just a few examples would be using low sulfur fuels. There are forms of combustion or combustion techniques which produce low nitrogen oxides, one of them including using catalytic converters inside an exhaust system, which we learned about in 9.4.1, or just going straight to renewable energy sources such as things like solar power, which do have no sulfur oxide or nitrogen oxide emissions. This last section now is just looking at 3 of the big questions that have been asked in the past on this particular focus area. The first one here is evaluate the impact of industrial sources of sulfur dioxide and nitrogen oxides on the environment, making use of appropriate chemical equations. The fact that it's plural suggests we need to put at least 2 equations in. So if I was writing this question, this is the logic I would use. First of all, I'd write down the equations of industry production of sulfur dioxides and nitrogen oxides. I'd then write the equations for acid rain and ozone formation and describe the negative impacts of acid rain and lower or tropospheric ozone. I would note that there are natural sources of these gases. This is my evaluation with the points for and against. There are natural sources, but then again there's evidence to suggest that the problems are anthropogenic. Then I'd give my judgment and criteria together, similar to the previous page. There has been a significant negative impact because of the harm that has been done to the natural environment. So my criteria of judging whether there has been an issue is yes, there has been harm to the natural environment. In a second I'll show an exemplar answer for this particular question. The next big question was a 4 marker here. The atmosphere contains acidic oxides of sulfur, which have been increasing in concentration since the Industrial Revolution. Discuss evidence for this statement and include relevant balanced chemical equations again. And so this is just focusing on oxides of sulfur. So I'll write down some equations of sulfur dioxide from industry with examples of where it comes from in industry. I'd show how sulfur oxides are acidic, first of all by showing the acid rain formation equations and then the reaction with calcium carbonate to show that yes, it is an acidic oxide, and that would link to my built environment damage I'm going to talk about in a minute. I'll then talk about the fact that we'll discuss evidence for this statement. I'll talk about the difficulties in measuring the concentration of these gases, but then I'd outline also the evidence that sulfur oxides have been increasing, and one of those bits of evidence is the fact that it's damaging the environment, and that links to that equation there, the dissolution of the calcium carbonate. Here's the marking criteria for that particular question if you're curious, so if you want to write an answer for that, you can come back and check if you have achieved all the things you need to get 4 out of 4. The last of the questions we're going to look at is this 5-mark question here. There's been an increase in the concentration of oxides of nitrogen this time in the atmosphere as a result of combustion. Assess both the evidence to support this statement and the need to monitor these oxides. So it's quite a long, complicated question. First of all, it's going to be basically exactly the same as the question above, except this time we're focusing on nitrogen oxide. So it's all the same as above question with sulfur dioxide, except to emphasize how combustion produces nitrogen oxides, so equations of nitrogen oxides and how they're produced in combustion. I'd also introduce the ground level ozone issues as well, because that's one of the problems these gases form. I would make a statement about the need for monitoring these gases, i.e. to provide warnings if there's going to be a big build-up of these gases, to identify sources of these gases so they can be eliminated, or also to monitor pollution reduction strategies to see if they can have been effective. So that's the reasons we need to monitor these oxides. And because it's an assess question, we need a judgment at the end too. So assess the evidence and the need. The evidence suggests that yes, these oxides are increasing, and also there is a need to monitor these oxides. These next two slides are just going to show you an exemplar answer from the Board of Studies for this particular question. I'll let you decide how good you think it is, and the marking criteria comes up after this. So feel free to pause as we go through this. The first page is here. Hopefully you can read that on your screen. And the second page is here.